Now let us see how to use the step deviation method to find the mean. This is also called as the change of origin and scale. So here what do we do is basically we define a new variable, say di, as xi minus a whole upon h, and the purpose of doing this is to simplify the calculation. Now in this formula the capital A stands for some assumed mean, that is we take tentatively some mean as per our choice, and small h is the scaling factor. So if it is possible to divide the numerator by some suitable denominator so that the entire number becomes a very small number to deal with, so in that case we divide by h, and hence lastly we get the formula for the original mean, that is x bar, as nothing but a plus h into d bar, where d bar is the mean of the new variable di defined, right? Let us solve one example so that this method will be clear. Now we took up the same example that we did earlier to calculate the mean, but now we will do it by the step deviation method. So we have the classes and the frequency. Like we have seen that the sum of the frequencies was 25. Now we need the class mark, okay, that is xi, right, and the class marks are 5, 15, 25 and 35. Now here we define a new variable di such that from xi we have to subtract some suitable assumed mean. Now as you can see, if you look at the data carefully, the most number of observations are concentrated in the class 10 to 20. So it is reasonable to assume that the mean also must lie somewhere in 10 to 20. So to take the advantage of the values of the class marks, we assume the mean to be 15. Okay, it is just the assumed mean, it is not the actual mean. Okay, so therefore from xi let us subtract 15, and let's mentally decide, if we subtract 15 from 5 we will get minus 10, if we subtract 15 from 15 we will get 0, then 25 minus 15 gives us 10, and 35 minus 15 gives us 20. So you see, these subtracted numbers, that is the results of subtractions, are themselves the multiples of 10, all of them, isn't it? So what do we do is we take a decision to divide that particular subtraction further by 10, so that this minus 10 divided by 10 gives us minus 1, then 0 divided by 10 gives us 0, 1 and finally 2. So you see, these numbers are so small so that we can easily work on their calculations. Okay, so now let us wipe out the unnecessary information here. Alright, so we have a new variable di ready with us. Now we work on this di, that is, first let us calculate the column of fi di, because we will have to calculate the mean of di. So fi into di, that is 3 into minus 1, the product is minus 3, so that's what we write here. Then 12 into 0 is 0, 9 into 1 is 9 and 2. So finally the sum is 8 if you add up. Now d bar is nothing but summation of fi di divided by summation of fi, so that stands for 8 upon 25. Let's keep it. Finally we have the formula of x bar as a plus h d bar. So a was our assumed mean, that was 15, plus h was the scaling factor, that is 10 here, multiplied by d bar turned out to be 8 upon 25. So that is equal to 15 plus 80 upon 25, that is 15 plus 3.2, which ultimately gives us 18.2, and this was the same answer that was obtained by the direct formula also. Okay, so this is the step deviation method. We use this method in case the calculations are slightly tedious, that is the values of the frequency and class mark, if they are bigger, then to avoid those big calculations we use the step deviation method.